morning, everybody. We are here in the shop and we are about ready to polish up the episode 2 of the video on our custom truck camper build. It's a flatbed camper. In episode 1 we went through the floor construction pretty quickly, but also discussed the design goals of making this camper versus our current Lance camper, which is an oldie but a goodie and definitely has served its purpose as a test bed for us on the Ford F350 that we also will be using. In this video, Steve goes through quite a bit more detail on the actual construction of the outside walls and the floor, and the roof should be almost done by the time we finish this. In the next video, we will actually be hopefully putting it together, maybe even putting it on the, getting the floor mounted and positioned on the truck bed so we understand how that fits and any changes that we might need to make there. And I hope you enjoy it. It's a long one. Stay with us. If you haven't seen the episode 1, please check it out on our YouTube channel. And there will always be more detail on our blog as we progress through this camper build. Have a great one.
Hello and welcome to my video detailing the detailed construction of the RV walls that I'm using in my camper build. In front of me here is a drawing showing the diagrams of the wall. This wall is constructed with 13/16 poplar material, 2 inches wide, pocket hold for joining. And in this particular case, I have the drawing here, and on the table here in front of me, I have all the pieces already cut and pocket hole drilled to begin assembly of stage 1 of the wall construction. And just to keep in mind what it is that we're building, here is the first wall that was built. This is the wall for the driver's side. That frame that you saw is now inside this wall. Additionally, the top section of the wall, which has already been built also and is assembled in the stack here, has been attached to it. The entire assembly has been covered first in 5mm poplar plywood. The windows are then reinforced with another band of poplar lumber, and the entire assembly is covered on both sides with 6-ounce fiberglass. This entire wall weighs in the vicinity of about 150 pounds. The top piece weighs 37 pounds. I could actually measure that, but I haven't been able to weigh the entire thing. So that is what we're doing today. So going back over here, the concept of the poplar frame is such that I want to have a perimeter board all the way around it so that I can attach it to other wall sections. I want to have, this is a window right here and here. So the windows are framed completely all the way around. When I place the 4x8 sheets of 5mm plywood on here, I don't want any of the edges of the plywood to meet in the same place. So what you'll see here is a pair of beams that are close together. So as you can see on the top here, there's a schedule that shows that there's a 48-inch spacing between this member and this member that accepts a sheet of plywood, and another sheet of plywood goes here, and then a remnant will be placed in this area here. And when I finish it from the other end, the plywood actually lands here and here and here and here, so that eliminates the joint. The sheets of plywood are offset by just a little over 8 inches to ensure that the integrity of the stress does not all concentrate on the inside and outside panels. Inside the wall is 2-inch thick polyisocyanurate foam with an R value of about 13, and it is placed in here in a 6-inch cube, and then the entire wall is made with 6-inch cubes and a piece with a space in between the 5mm piece of plywood. So you have a grid work of 5mm plywood on edge and 5 7/8 inches of foam in between each one of them, which will see a little bit later. So to begin with, I am using my table as a fixture. The table is leveled and flat within about 1/16 of an inch over its 8 by 12 feet spacing, and I have the members are all clamped to the table here and using it as a large square so I can make sure that the top and the rear edges of the wall are very square to ensure that I'm creating and building a square wall. The additional help of the 4x8 sheets of plywood on here is an additional squaring mechanism used. This particular, I did screw this one corner together. The pocket screw method is a very effective and very strong technique for gluing walls together. I'm using a Titebond 3, which is waterproof adhesive. On this, it's water soluble until it is fully cured, and at that point it's waterproof. The screws are a standard pocket hole chrome plated screw. They're 1.25 inches long. And that's simply how they go together. Most of the features of the wall you can see right here where I've actually marked where the member goes, but I actually have each piece that actually mechanically holds it in place. This piece goes down over here, but it doesn't really take too much to assemble this pretty quickly. I get a little bit of glue on each member, spread it around pretty well. Make sure I use plenty of glue here and place it okay. Step 1 is now complete. The entire frame is fastened and glued, and step 2 is to apply the plywood, 5mm poplar plywood, to the outside of it. This will take about 6 sheets or so of plywood. The plywood is designed so that it doesn't all lap in the same place. As I think I may have explained before, the first sheet will go from here and stop here, and then on the other side, the first sheet will start here and run to here, so that I get about 8 or 9 inches of overlap in the sheet, so that I don't have a stress issue. Applying this is pretty straightforward. I apply glue to the edge of the frame. I lay the plywood on there. I staple it with 5/8 1/4-inch narrow crown staples, and then I use a trim router to trim it off. I'm going to put 2 sheets on this side, followed by 1 sheet on the overhead and a partial sheet down here in this small space. When I start at the end, I ended up with a small space, so I end up with a small space. We'll have a partial sheet on it, which I say is about 10 inches wide. And then this is the doorway, and the doorway is remaining open. And the problem will be that the doorway will be a major strength issue for the wall, at least until the top facet is installed. So that's just something I have to contend with. The brace that's in the middle of the doorway, as you can see right there, is just a temporary brace. It's just designed to hold it and keep it from flopping around or breaking when I flip it over. Okay, we're done with step 2. The frame is skinned, it's stapled, it's trimmed, it's flipped over, and now we are going to perform the structural support that's going to make this wall much stronger. We're going to build what is referred to as a torsion box, which is a 3-dimensional representation of an I-beam. In this particular case, the way we're going to do it is we're going to place a piece of foam in the cavity, and this foam is 2 inches tall, just a little bit less. And then this is the way that we're going to create this box. Is we're going to take a piece of the same plywood that makes the structure, and we're going to place it in between the foam so that the plywood has the support on the outside. And we're going to do this on approximately a 6x6 grid for the walls. I've used a 4x4 grid for the floors, and this is a 6x6 grid for the walls. You'll see that this piece of foam is not exactly 6 inches square, but it's not critical. It's followed rigorously. What I'm trying to do is to make sure that I have good close bearing, so this panel that comes on the other side here will have a 6-inch support right at the end here. The last piece of material has to be trimmed. You can do it with a knife, you can do it with a saw. It's not necessary that it's precise. The foam does not provide structural support, so having it tight is simply a luxury. And we're going to continue all the way down until we've completed this section, and then we'll start with the standard 6x6 grid in the next section. I'm dipping these pieces of plywood in glue, and there's quite liberal amounts of glue on it, and it's really a nice feature of the glue is that it does not set up very quickly. This wall, I'm going to do this an 8 or a 4 foot section at a time, and what I'll do is I'll do 4 feet, and then I'll place glue on all the stringers, and I'll put the sheet of plywood on here, and I'll place some weight on top of this so that the plywood has a chance to settle into this material right here, and that will keep it nice and tight as the glue cures. It takes probably, well, it's pretty warm today. It's in the mid-80s today, so the warmth for this glue job is definitely a motivator to work quickly. And there we have it. That's what the filled bay looks like. And now we're going to start on the section down here. This is the window right here where I just set this material. This right here, section right here is the window. So it doesn't get anything. The plywood is simply there to keep everything square and straight until I get it done. And so now I have a can full of 6x6 material here. It's actually 5 7/8 because I want to minimize my waste, and actually, as you can see, with using a 6-inch piece, the waste is pretty minimal anyway. So the way that I do this is I have a box of pre-cut material. A bunch of this is 6x6 or 5 3/4 or so. It's just a slightly shorter, and I continue now in 2 dimensions where I previously only had 1. And I'm going to actually cut that next section. You notice it's just almost long enough, and instead of stopping here, I thought I'd take a minute to throw in a couple additional comments about this structure and how I'm putting it together and why I'm doing it this way. For instance, to start with, this is a 3-ply plywood. The end grains of the two plies run this direction, and that is what I'm looking for, is the compressive strength of the end grain. So that is why this plywood is put in this orientation, and I think it's somewhat important that it is. If you were to put a piece in like this, you would have 1 piece of end grain here and 2 pieces of face grain, which would not be as strong. In my construction, I initially started off cutting these 2-inch strips out of an entire sheet, but I have now so many window openings and offcuts that I have more than enough material to do all of these small pieces in what would normally be a very small and otherwise unusable piece. So that these pieces are almost free in some respects. One of the other comments is if you can see, this is a 6x6, 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 and about 6 by about 3.5. And then I start with the 6-inch on the other side, and what this does is it prevents these 2 seams from lining up. And the reason why I do that is that it forces this center piece to be a little bit flexible because you can see the cross piece is just a little bit longer than the foam is. That's the way I can ensure that those two end pieces touch. But it's also a method for making my section very tight. With this center web doing a little S bend as it goes through here, it provides some springiness and some compressiveness. And the last closing block that I put in here was fairly tight, and I benefit from the ability to put that in by being able to compress these strings. If I put it very tight this way, it's very difficult to side load it this way, so when I do put them together, I do place them in there fairly tightly, because I don't want any movement after the fact. I don't think that that's probably an issue, even if there were to be movement. I've never done one of these in real time. This section here, it's probably about 6 or 7 square feet. Took me about 10 minutes to do, kind of give you an idea of how fast it goes. One other comment is, it's easy to dip these things into the glue to get the edges glued, but the longer ones, I don't have a tray big enough, so I have experimented with several different techniques to do it, and this is the one I like the best, is just a chip brush and just literally wipe the glue right off the edge of the brush onto the part. Seems to work pretty well, and that's all it really takes. One additional comment: it's been shown in woodworking circles that just putting the bead of glue on the edge of the wood and allowing the material that's to be bonded to it to squish the seam out is not nearly as effective as it is to actually brush it out and work that glue into the grain of the wood just a little bit. So all of my final steps in gluing this outer covering on is to put a good solid heavy bead of glue on here and brush it out. I think it's pretty important. It also, one of the things that it does, it helps to keep the glue from running off the edge since you spread it out. Although there's runs, and there's plenty of runs in this. One comment on the glue: this is Titebond 3, as I said before. It's a fully waterproof glue, and it's got a great open time. Right now it's about maybe 70 degrees here in Southern California, so I noticed yesterday afternoon when it was in the high 80s that I had to really hurry in order to get a 4x8 section done. Actually, it's about a 4x7 foot section done in time to prevent it from drying out. This particular one, you can see the glues are pretty moist in most places. There's a couple of times I might have touched it and lost my seam, and I can touch some of those up, and sometimes I do. More often than not, I don't. I think there's more than enough bond area here that's going to be functional without any additional effort. Anyway, here I staple it down with 5/8 leg 1/4 inch crown staples about every 3 to 4 inches on center, and I let it set for a day with some weight on it. So that's where this project is headed right now. Okay, it's another day. Yesterday I completed the construction of the body side of the camper frame. Today we're going to work on this small section here on the overhead, and then we're going to work on attaching the top facet to the panel, which is going to make the panel stiff enough to manipulate. Right now that's pretty floppy, with the door opening being right here. I have a temporary brace in the center, but it doesn't really strengthen it very much, and now that it's heavier with both skins on site, I would be very hesitant to try to flip it over.
The faucet and roof design improve our ability to brush off tree branches and not have anything catch on the camper when encountering low-hanging tree branches. There will also be aluminum armor facings along the top edge of the roof, shielding all the roof projections and the solar panels. And there you have it. The passenger wall is standing up, the driver's side wall is laying down, and the floor is right underneath of it. The roof is partially done now, and next video, things should get a little interesting with trying to assemble it.